Hey, what's going on, guys? We have a thermodynamic cycle right here. The question is asking to find the total work, right? So let's see how we can find the total work for these kind of problems. So first of all, we have to create an equation. We know that if we add all the work, like it's going cycle. If I add this process plus this process plus this process, that's going to give us the total work, right? So let's say this is 1, 2, 3. It's already mentioned right here. Let's rewrite this one. 1, 2, 3. So the total work is going to be WT is going to be W1 to 2, W1 to, let's put arrow right to make it clear. So this is going to be W1 to 2 plus W2 to 3 plus W3 to 1, right? W3 to 1. So this is going to be the process. So let's analyze each of this and see what is the work done for each one, right? So if you look at this 1 to 2, it's an isochoric process because the volume is constant. So this is an isochoric process. So whenever we have isochoric process, the work done is always 0, right? You can look at this in two different ways if you want to make sure. If you use W is equal to P delta V, the delta V is going to be 0 because initial and final volume is going to be same. So delta V is going to be 0. So if you multiply 0 by P, that's going to give us the work 0. Or if you want to look at through the PV diagram, you can draw that one separately, right? So in PV diagram, if you draw this line right here, if you look at the area under this one, so whenever we have PV diagram, like for example, to calculate any work, we just look at the area under the line, right? But this line is vertical, so we don't have any area under this line. So this is automatically tells us this is 0. So this way you can make sure that it's always 0. So whenever you have volume is constant, the work done is always 0. So you can put the 0 right here. So W1 to 2 is going to be 0. Let's look at W2 to 3, right? So 2 to 3, they say this is an adiabatic process. So whenever we have adiabatic process, the Q is always 0, right? The Q heat is 0. And from first law of thermodynamics, we know that delta G is equal to Q minus W. So if Q is equal to 0, then delta G is going to be equal to 0 minus W, right? Delta G is equal to 0 minus W. Therefore, we can directly say delta G is equal to minus W. So if delta G is equal to minus W, W is equal to minus delta U, right? If I rearrange this one. And for U, we can always calculate U by using this equation. U is equal to NCV delta T, right? So this is the generic formula, like always it's true. Like some of them say if it's constant pressure, you have to use NCP delta T, right? It's not true, like it's for Q. If you want to find heat, that's in constant pressure, you use NCP delta T, in constant volume, NCV delta T. So that's change according to the situation, but this one always same thing. So here we have negative delta Q. So this work is going to be negative NCV delta T, right? So that's going to be the equation at 2 to 3, because since it's an adiabatic, this is going to be the equation. So we can directly say plus minus NCV delta T, and that's going from 2 to 3, right? So this is going to be 2 to 3, and let's look at 3 to 1. 3 to 1, if you look at this one, this is an isobaric process because the pressure is constant. So this is an isobaric process. So whenever we have isobaric process, we can use this equation. W is equal to P delta V. So we can use that equation to find the work done right here. So we can directly plug P delta V, and let's look at through one by one, right? So if I want to find the 2 to 3, I have to know T2 and T3. But here they only provided T1 right here. So let's see how we can calculate T2. So we have to find out the way to calculate T2. There are many different equations we can use, but if you look at the ideal gas law, let's see ideal gas law whether it will work or not, right? Let's see. PV is equal to nRT. Do we have all the values? P2 we have, V2 we have, because volume is constant. and V2 is 20 liters. So V2 we have N is provided 1 mole. We have to find the T2. So we can use this equation to find the T2 from ideal gas law. So let's plug the values and find the T2 from this one. So from this one, T2 is going to be equal to P2 V2 divided by NR, right? So here we have P2, that is 2 ATM, times volume 2 is going to be 20 liter. So whenever we have ATM times liter, to convert this one into joule, we have to multiply this one by 101.3 joule per ATM liter. So that way it will cancel each other and give us the joule, right? And in the bottom we are going to have 1 mole time R, that's gas constant, that's going to be 8.31 joule per mole Kelvin. And if you calculate this one, that's going to give us the answer in Kelvin. And let's see what we get from this one. If you plug all the values in calculator, you get 487.6 Kelvin. So that's going to be the value for T2. Since we have T2, but we also don't know the T3, right? So we have to calculate that one too. So to find that one, let's see whether ideal gas law works. P2, do we have P3? We have P3 because pressure is constant. P1 and P3 same, 1 atm. Do we have V3? We don't have the V3, so we can't use ideal gas law to find the T3, but we can use another different equation. That is T2 V2 alpha minus 1 is equal to T3 V3 alpha minus 1. Actually gamma minus 1, right? Gamma minus 1. In this case, again, we don't have the V3, so we have to do something else, right? We have to find the V3 first. If we can find the V3, we can use ideal gas law or this one. So let's see whether we can find V3. To find the V3, we can use another equation, that's P2 V2 gamma power gamma is equal to P3 V3 gamma. So let's see whether we have all the values, right? P2, do we have that one? Yes. P2, yes, we have. P3, yes, we have. That's 1 atm. And V3, we can calculate this using this one. Gamma is basically Cp over Cv ratio. So gamma is Cp over Cv ratio. So here Cp, so since they have mentioned this is monoatomic gas, we can find the Cp-Cv ratio, because for a monoatomic gas, Cp ratio always going to be 5 over 2 R, right? Cv ratio is going to be 3 by 2 R. And if it's diatomic, Cp is going to be 7 over 2, Cv is going to be 5 over 2. And if it's triatomic, it's going to be 9 over 2, Cv is going to be 7 over 2. So it goes like that. But since we have monoatomic, we can use this one. And if you use this one, this 2 cancels each other, RR cancels each other, and we get 5 over 3. And 5 over 3 gives us, let's plug in the calculator, that gives us 1.67. So 5 over 3 gives us 1.67. All we have to do is simply plug this power and find the value, right? So here we have P2, V2. Let's rearrange this equation. Here we are trying to find V3, right? So V3 power gamma is equal to P2 V2 power gamma over P3. So here what I can do, I can take the gamma root. So to find the V3, I can take the gamma root. So this is going to be V3 is equal to gamma root P2 V2 gamma over P3. So here we have P2, that is 2 atm, and then we have V2 is 20 liter power gamma, so gamma is 1.67, and then whenever we have atm liter, to convert this one, into joule, we have to multiply this one by 101.3, right? So this is what we have to do. And then you know what, since this is a liter, because in the bottom we are going to have a problem if we keep this one in liter, because we have this one in ATM, this one in ATM. So it's better to change everything in SI unit, right? So it's better to change everything in SI unit and then do the calculation. So here, instead of liter, what I can do, I can write, we know that 1 liter is equal to 1000 meter, meter cube, right? 1 liter is equal to 1000 meter cube. So to find the 20 liter, we have to divide 20 by 1000. So 20 by 1000, that's going to give us what? 0.02 meter cube. So we can convert this one in meter cube. So let's write this one in meter cube. So I erase this one and write this in meter cube. So this is going to be 0.02 meter cube. So if it's in meter cube, I have to convert ATM into Pascal because I have to maintain the SI unit, right? So to convert this one into Pascal, I have to multiply this one by 1/300. So let's multiply this one. So this is going to be 2 times 1/300 Pascal. 1/300 Pascal. So Pascal is basically Newton per meter square. It's better to write Newton per meter square because we can see the units cancel each other and finally we get meter cube, right? So this is going to be Newton per meter square, or just get rid of the units for now. Finally we can put meter cube. And then in the bottom we have 1 ATM. I have to convert that one into Newton per meter square too. So I had to multiply that one by 1/300. So this is going to be 1/300. All of them are in gamma root, right? This is not 3 actually. This is 1.67 gamma root. So this is first put gamma. This is 1.67. And then if you calculate, if you plug these values in calculator, you are going to get value that's going to give us a 0.0303 meter cube. So that's the value we get. Since we have this one right here, now what we can do, we have V3 gamma. Now we are trying to find T3, that's our purpose, right? So let's go to this equation again, or you can use PV is equal to nRT because we have V3 already, and we can P we already have, V3 we have, nRT. You can use this equation, or you can use T2 V2 power gamma minus 1, T3 V3 power gamma minus 1, both will work. So let's for this is a new equation. We used to use ideal gas law. Let's do it by this equation, right? So let's do this. Use this equation. This is going to T3 is going to be equal to T2 V2 power gamma minus 1 over V3 power gamma minus 1, and that's going to give us 460. That's going to be okay. We know the T2. Did we calculate that one already? It's right here. Yeah, that's 487.6 Kelvin times V2 gamma minus 1 is going to be power 1.67 minus 1. So there's going to be 0.67. So V2 power 0.67. V2, what is the V2? That's 20 liter, right? So if it's ratio, we can keep the same units, like liter is going to cancel. I can take the gamma minus 1 common, and so we can write V2 over V3 power gamma minus 1 because both of them have the same power. So I can take this one common. So let's divide this one, V2 over V3. V3 we have 0.303. So if I want to keep the unit, I have to convert both of them in meter cube or both of them in liter. So let's convert this one into liter. To convert meter cube into liter, I have to multiply this one by 1000. and that's gonna be 30.3, right? 30.3, and in the top we know that V2 is 20 liter, so 20 power 0.67, and that's gonna give us 369.2 Kelvin. So now we have these values, so it's like too much crowded, I mean too many places. So let's raise something. NCV delta T. So all we need is delta T. Since we have T3 and T2, now we can go ahead and plug it in the equation, right? So let's do the calculation. Okay, I erase this part right here. Okay, so let's continue everything inside here. So here we are trying to find minus NCV delta T. Minus N is 1 mole. And then we have CV. So CV for monoatomic gas is going to be 3 by 2. So this is going to be 3 by 2 R. 3 by 2 R. Then delta T is going to be final minus initial. So it's going from 2 to 3. So it's going to be T3 minus T2. T3 we calculated already. It's 369.2 Kelvin. Right? So this is going to be 369.2 Kelvin minus 487.6 Kelvin. And if you notice this one already, this is going to be negative answer because we are subtracting bigger value from smaller. So this is going to be a negative value, and we already have a negative in front of this. So negative times negative, that's going to give us a positive answer. And if you calculate this one, that's going to give you 1476 joule. So this gives us 1476 joule. Now we have this part, 2 to 3. So this is 1476 joule. So this is what we tried to find out until this time, right? Now we have to go for the 3 to 1. 3 to 1, if you look at this one, this is an isobaric process because the process is constant. Here we can use P delta V equation. So this is going to be W is equal to P delta V. So P is constant, that's 1 atm. 1 atm. Delta V is going to be final minus initial. So it's going from 3 to 1. So 1 is going to be the final. 20 minus initial is 30.3 right here. Because this is in meter cube, I have to convert this one into liters. So this is equal to 30.3 liter right here. Therefore, this is going to be 30 point. Actually, my final is 20 right here. Right. So this is going to be final minus initial. 20, final is 20. Yeah. 20 minus 30.3 liter. So whenever we have atm liter, we have to convert this one into joule because we want the work in joule, right? So to convert this one into joule, we have to multiply this one by 101.3 joule per atm liter. So that's going to convert this one into joule. And if you calculate this one, that's going to give you negative 1043. And from this diagram, you can already find that this is going to be a negative answer because whenever in PV diagram, whenever we have in this direction, that's the work is going to be positive. If the arrow is in this direction, the work is going to be negative. Since this is in this direction, we know that work is going to be negative and we calculated it's negative. So let's plug these values. So we found out this one. This is minus 1043. So let's rewrite everything. WT is equal to W1 to 2 plus W2 to 3 plus W3 to 1. 1 to 2 is 0 because it's an isobaric process. W2 to 3 we calculated, that's 1476 joule, and W3 to 1 that's going to be negative 1043. and if you calculate all of them, that's going to give you 433 joule, and that's going to be the final answer. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.